Hello there! Welcome to Science for High School with Merivit Education Center. This series is for M.2. I'm Master Rick. Today we will be talking about work and power, their relationship as well as their differences. If you're ready, come along with me. Let's learn.
When a force acts upon an object to cause a displacement, it is said that work was done upon the object. Now, there are three key elements to work: force, displacement, and cause. In order for a force to qualify as having done work on an object, there must be displacement. If the force is constant, work may be computed by multiplying the length of the path by the component of the force acting along the path. Now, to express the concept mathematically, the work W is equal to the force F times the distance, or W is equal to F times D. Now, the SI unit of work is the joule, which is defined as the work done by a force of 1 Newton in moving an object through a distance of 1 meter in the direction of the force. Work is done when a force that is applied to an object moves it. Now, when a force acts to cause an object to be displaced, three quantities must be known: force, displacement, and the angle between the force and the displacement. The work is subsequently calculated as force times the displacement times theta, where theta is the angle between the force and the displacement vectors expressed in cosine. If a force is applied but the object does not move, then no work is done. If a force is applied and the object moves a distance in the direction other than the direction of force, then less work is done than if the object moves a distance in the direction of the applied force. Now, if an object is moving with a constant velocity at right angles to the motion, then no work is done. Work can either be positive or negative. If the force component is in the same direction as the displacement of the object, the force is doing positive work. If the force component has a direction opposite the displacement, the force then does negative work.
What is power? Power is not how strong you are or how big your muscles are. No, it's not. In physics, power is the amount of energy transferred or converted per unit time.
So, what is power? Power is a measure of the rate at which work is done, or similarly, at which energy is transferred. The standard unit to measure power is the watt, which has the symbol W. The unit is named after the Scottish inventor, James Watt. By definition, 1 watt is equal to 1 joule of work done per second. Here are sample problems to illustrate work and power.
Now here is problem number 1 for calculation of work done. Let's say I have a box and I'm pushing it across a room with a force of 279 newtons. Let's say I move the box to about 378 centimeters. How much work was done on the box? Now in this problem, we need to calculate the work done. A force of 279 newtons is applied to push a box to within 378 centimeters. To calculate, force times distance will be equal to the work done. But for the distance, we need to convert the centimeters into meters to get the proper unit of joule, which is equivalent to Newton meter. Now, I'm going to give you a few seconds to think about the problem and to solve it. And if you are ready already, we will show you the answer later on. Did you get the answer? A force of 279 newtons times the distance of 3.78 meters, work done is equal to 1054.6 joules. Did you get the same answer as mine? Good job! And finally, we have problem number 2 on calculation of power. A heavy steel ball was rolled across the floor to a distance of 7.2 meters in 6.8 seconds with a force of 385 newtons. Now calculate the power generated in moving the steel ball across the floor. Now for this problem, we need to calculate the power. The problem is the heavy steel ball rolled on the floor with a distance of 7.2 meters in 6.8 seconds with a force of 385 newtons. Now, in order to calculate power, we need to get the work done by multiplying the force, which is 385 newtons, and the distance of 7.2 meters divided by the time, which is 6.8 seconds. Then we will get the value of, right, I'll give you a few seconds to think about the problem and calculate your answer. Do you have the same answer as mine? The value of the power is 407.6 watts. Do we have the same answer? Good job! And that's it for work and power. I'm going to see you again in the next episode. Don't forget, science is cool.